Problem number 3. On Wednesday, Andrew got up late, so he had to run to get to school on time. After school, he walked home and stayed there several hours until he returned to school for a band concert. After the concert, he walked straight home. Which graph below depicts this situation? All right, before I even look at my problem again, I want to kind of glance at these graphs. And I notice every one of them is distance and time, distance and time, distance and time, distance and time. So that means as time goes on, I want to see what it is that my distance is doing. And I'm assuming since they're talking about him leaving home and going to school, we're talking the distance from home and then back to home. So I'm going to read the problem and kind of pick out all of the things that I can think of throughout the day that he would have done, and then I want to match up which graph has all of those things in it. So it says on Wednesday, nobody cares what day it is, Andrew got up late, so he had to run to get to school. So he got up late, he had to run to get to school. So I should see on my graph, run to school. Then it says after school. Now I didn't just run to school to turn around and leave after school, so I need some time at school. Then after school, he's going to walk home. So he walks home and stayed there several hours. So he stayed at home for a while. Until he returned to school. So he goes back to school. And I'm assuming he's walking, because it didn't say he was in a hurry to run, for a band concert. After the concert, okay, once again, he's not just going to arrive for the concert and then leave. He's going to stay for the concert. So he's at the concert for a while. And then, after the concert, he walked straight home. So walks home. Which graph below? Okay, that's just our question, which depicts the situation correctly. We want to look for these key things. I'm going to start with answer choice D, just to be different. I need to first look for him to run to school. So if he's running to school, he's going to be further away from school. So that part makes sense. He's at school, so he's hanging out there a while. So his distance isn't going to increase or decrease because he's staying at school. Then it says he walks home, so I can see him getting closer to school, but he doesn't actually ever reach back to home. Remember, home would be at a 0 distance away from home. So he doesn't actually reach home. So this part would knock this one out because he's not going to ever get back home. Let's look at C. He's going to start off running to school, and then when he gets to school, he's going to turn around and run back home. Remember, that leaves out the hanging out at school for a while, so this one's probably not accurate either. This one I would expect to level off somewhere because he's going to stay at school throughout the day. Answer choice B. He's going to run to school, so that's taking off for school. He's going to stay at school for a while. He's going to run home, he's going to walk home, and then he's supposed to stay at home. If he stayed at home, it would be flat down here too, but you'll notice in this graph, as soon as he got home, he turned around and started walking back. So this one's not going to make sense because this part isn't where he's staying at home for a while. Let's check out answer choice A. He runs to school very quick. Notice it's very sharp slope. It points up very quickly. Then he's at school for a while. Then he walks home. It's a little less sharp coming home. Then he's at home for a little while. Then he walks back to school. He stays at the concert for a little while. And then he walks home. So it looks like graph A has all of the parts of the story that we were looking for.